Okay, so today we're going to be discussing solving systems of equations graphically. Today is February 5th, although you'll probably be listening to this February 4th. So let's move on. Take out your notes and let's talk about the steps in solving our systems. We're going to write each equation in function form. Function form, y equals mx plus b. Remember that b is your y-intercept and m is your slope. Going to tell us how to graph our lines. Our goal is to find the point where the two lines intersect. This will be our solution to both equations. We will be then checking our solution in both equations in their original form. Okay, here we go. First we have to ask ourselves, is my equation in y equal mx plus b format? It is not, so I will be moving things around. I'm going to move that y to the other side, and then since I want it to be alone, I will take my 1 and bring it to the other side. That will result in y equals x plus 1, giving me a slope of 1 and a y-intercept of 1. Again, your slope is the number before the x, and your y-intercept is your b. Okay, let's get our other equation in the form that I want it to be. I'm going to move that x to the other side by subtracting it, and I will get negative x plus 3. My slope will be negative 1, and my b will be 3. Now, how do I graph this? Well, we always start at our y-intercept. Y-intercept. So to graph the first equation, y equals x plus 1, I'm going to start at 1, and slope is up 1 over 1, up 1 over 1, up 1 over 1. Using a straight edge, I'm going to graph my line. Please make your lines long enough so wherever it does happen to intersect, your line will be long enough to show the intersection. Okay? Alright, let's graph the other line. Y equals negative x plus 3. I start at my b, which is 3. And my slope is down 1 over 1, down 1 over 1, down 1 over 1. Noticing where the point of intersection, I can see it already, is right there. Let's finish up this graph. Line. And of course we have to label our lines, making sure that there are arrows on the end of each line. Here is y equals x plus 1, and here is y equals negative x plus 3. The point of intersection is here, and that point is over 1 up 2. So let's finish off. 1, 2 is the point of intersection. That's the point that I'm going to be checking in each of the original equations. So I'll start with one of my original equations, which is x minus y equaling negative 1, plugging in my point of intersection, 1 minus 2. Does it check? -1 equals -1. It does. Now let's check our other equation. Again, using the original equation. One plus 2, we're getting those numbers from our point of intersection. 3 equals 3, check. Those are all the steps in solving systems of equations graphically. So we will do another one together, and then I would like you to try one on your own. Alright, so step 1, we want it to be in y equals mx plus b format. My first equation is, so I don't have to do any manipulating, m is 2 and b is 3. I can graph that. Remember, I start graphing at the y-intercept. Starting at 3, there is my 3, 0, 3, and my slope is, remember, rise first, run second. So we are going up 2 over 1, up 2 over 1. You probably just need 3 points connecting those points. Labeling your line. And now let's take a peek at the other equation. This guy is not in y equals mx plus b format. So let me rewrite it where I have some space to show work. I have to get my my y by itself, which means I have to divide by 3 on every single term. That gets rid of that. This becomes a 2, and this becomes a 2. So to rewrite this equation now in simplified form, I will have y equals 2x minus 2. Immediately write this so you know what you're dealing with. Remember, the sign in front of the number goes to the integer that follows it. Let's plot those. We start at my y-intercept at -2, and slope is up 2 over 1, up 2 over 1. There are my 3 points. And you should immediately see that you have parallel lines. There is no point of intersection. Why? Parallel lines have the same slope, and they will never intersect. 3 dots means therefore they, being the lines, will never intersect. Now we should have immediately noticed that my slopes being equal, I would not have a point of intersection. So in this situation, we have no point of intersection. I want you to take a moment or two, or however long it'll take you. I want you to do the next 3 examples on your own. I want you to try 3, 4, and 5. If you need to go through the lesson again, please rewind and listen to it again, watching very slowly how we went through and solved each of the first 2 problems. Good luck.